Hello students, to begin with, let us see to the solutions of the problems I gave you for the home assignment. Question number 1, limit pi r square as r tends to 1. Look at the solution. We have limit pi r square as r tends to 1 is equal to pi into 1 square, that is equal to pi. For question number 2, limit 4x plus 3 upon x minus 2 as x tends to 4 can be simplified as limit 4x plus 3 upon x minus 2 as x tends to 4 is equal to 4 into 4 plus 3 upon 4 minus 2, that is 19 upon 2. Question number 3, limit x to the power 10 plus x to the power 5 plus 1 upon x minus 1 as x tends to minus 1. For the solution, look, limit x to the power 10 plus x to the power 5 plus 1 upon x minus 1 as x tends to minus 1 can be simplified as minus 1 to the power 10 plus minus 1 to the power 5 plus 1 upon minus 1 minus 1, that is equal to 1 minus 1 plus 1 upon minus 2, that is equal to minus 1 upon 2. Now, let us discuss about the algebra of limits. In these illustrations, we have observed that the limiting process respects addition, subtraction, multiplication and division as long as the limits and functions under consideration are well defined. Here, we formalize these as a theorem. Let us see theorem number 1. Let f and g be two functions such that both limit f of x as x tends to a and limit g of x tends to a exist. Then, first, limit of sum of two functions is sum of the limits of the functions, that is limit of f of x plus g of x as x tends to a is equal to limit of f of x as x tends to a plus limit of g of x as x tends to a. Second, limit of difference of two functions is difference of the limits of the functions, that is limit f of x minus g of x as x tends to a is equal to limit of f of x as x tends to a minus limit of g of x as x tends to a. Third, limit of product of two functions is product of the limits of the functions, that is limit of f of x into g of x as x tends to a is equal to limit of f of x as x tends to a into limit of g of x as x tends to a. Fourth, limit of quotient of two functions is quotient of the limits of the functions whenever the denominator is non-zero, that is limit of f of x upon g of x as x tends to a is equal to limit of f of x as x tends to a upon limit of g of x as x tends to a. Now, let us look into the limits of polynomials and rational functions. A function f is said to be a polynomial function if f of x is 0 function or if f of x is equal to a0 plus a1x plus a2x square plus an x to the power n, where ai's are real numbers such that an is not equal to 0 for some natural number n. Limit x to the power n as x tends to a is equal to a to the power n. that is limit f of x as x tends to a is equal to f of a. A function f is said to be a rational function if f of x is equal to g of x upon h of x, where g of x and h of x are polynomials such that h of x is not equal to 0. Then limit of function f of x as x tends to a is equal to limit g of x upon h of x as x tends to a is equal to limit of g of x as x tends to a upon limit of h of x as x tends to a is equal to g of a upon h of a. Now, let us solve some examples to understand this. Example number 1, find the limits limit x cube minus x square plus 1 as x tends to 1. Here for the solution, the required limits are all limits of some polynomial functions, hence the limits are the values of the functions at the prescribed points. So, we have for the first one limit x cube minus x square plus 1 as x tends to 1 as 1 cube minus 1 square plus 1, that is equal to 1. For second, limit x into x plus 1 as x tends to 3 is equal to 3 into 3 plus 1, that is obviously 12. For the third, as limit 1 plus x square plus so on till x raised to 10 and x tends to minus 1 can be solved as 1 plus minus 1 raised to 1 plus minus 1 raised to 2 plus so on plus minus 1 raised to 10 is equal to 1. Example number 2, find the limits of the functions. First question, limit x cube minus 4x square plus 4x upon x square minus 4 as x tends to 2. And question number 2, limit x square minus 4 upon x cube minus 4x square plus 4x as x tends to 2. Here both the functions are rational functions. Hence, we first evaluate these functions at the prescribed points. If this is of the form 0 upon 0, we try to rewrite the function cancelling the factors which are causing the limit to be of the form 0 upon 0. Now, look at the solution. Evaluating the function at 2, it is of the form 0 upon 0. Hence, we can simplify limit x cube minus 4x square plus 4x upon x square minus 4 as x tends to a as limit x into x minus 2 whole square upon x plus 2 into x minus 2 as x tends to 2. Can you find something common in numerator and denominator? We can cancel out x minus 2 and thus it can be simplified as limit x into x minus 2 upon x plus 2 as x tends to 2 as x is not equal to 2. That is equal to 2 into 2 minus 2 upon 2 plus 2, that is equal to 0 upon 4, that is equal to 0. Now, for the second part, evaluating the function at 2, we get it of the form 0 upon 0. Here limit x square minus 4 upon x cube minus 4x square plus 4x as x tends to 2 can be rewritten as limit x plus 2 into x minus 2 using the formula a square minus b square is equal to a plus b into a minus b upon x into x minus 2 whole square. Here again you find something common? Yes, x minus 2 can be cancelled out from numerator and denominator, which reduces to limit x plus 2 upon x into x minus 2 as x tends to 2, that is equal to 2 plus 2 upon 2 into 2 minus 2, that gives us 4 upon 0, which is not defined. Now, let us look into an important theorem. For any positive integer n, limit x to the power n minus a to the power n upon x minus a as x tends to a can be written as n into a to the power n minus 1. Here an important remark, the expression in the theorem for the limit is true even if n is any rational number and a is positive. Now, let us solve an example using this theorem. Evaluate limit x to the power 15 minus 1 upon x to the power 10 minus 1 as x tends to 1. We have limit x to the power 15 minus 1 upon x to the power 10 minus 1 as x tends to 1. This can be written as limit x to the power 15 minus 1 upon x minus 1 divided by x to the power 10 minus 1 upon x minus 1. That can be separated as limit x to the power 15 minus 1 upon x minus 1 divided by limit x tends to 1 x to the power 10 minus 1 upon x minus 1. Using the theorem, of course, we have 15 into 1 raised to 14 divided by 10 into 1 raised to 9, that is equal to 15 divided by 10, that is equal to 3 upon 2. So, students, today you studied about algebra of limits. I hope you have understood. Now, it is time to take up assignment. Question number 1, evaluate the following limits. Limit x plus 1 raised to 5 minus 1 upon x as x tends to 0. Question number 2, limit 3x square minus x minus 10 upon x square minus 4 as x tends to 2. Question number 3, limit cos 2x minus 1 upon cos x minus 1 as x tends to 0. In the next session, we shall study about limits of trigonometric functions and some important theorems. Thank you.